Hi, everyone. My name is Gabriela Leite. I'm from the MAST Program at Cedars-Sinai in LA. And I'm presenting a poster that was presented at the ENDO 2026, where we are showing the results of Gavage in rats with Rothia Mucilaginosa, which is a human duodenal microbe that leads to a PCOS phenotype and change in the small bowel microbiome. So PCOS, that was recently renamed to PMOS, is one of the most common disorders affecting reproductive age women. And although the etiology of this condition remains incompletely understood, we understand that the gut microbiome may play an important role in this pathogenesis. And some previous studies identified associations between specific microbial populations and features that we commonly see in PMOS. Previously, we have demonstrated that Rothia Mucilaginosa, a bacterium that's found in the human small intestine, especially in the duodenal, induce a PCOS-like phenotype in rats and is characterized by abnormal astrocycles, dysregulated ovarian physiology, and insulin resistance. So for this poster, we decided to investigate whether this microbe colonizes and also engrafts and perhaps alters the small bowel microbiome in an in vivo model of PMOS. With this purpose, we gavage female sprog dolly rats with Rothia mucilaginosas for 4 weeks daily. And after we finish this first 4 weeks period, we stop gavages and we follow up a second group of rats for extra 4 weeks. And we collect blood at the end of this period. We dissect these animals and we collect the content of the small bowel. We extract DNA and we perform whole metagenomic sequencing to characterize the microbiome and also to quantify the amount of Rothia mucilaginosas in the bowel. We utilize a total of 80 rats for this study. After the initial 4 weeks gavage period, 55% of the Rothia group rats showed altered astrocycles with arrested diestrose phase compared to 30% in the control group, and that can be seen in the figure 1A and B. In terms of bacterial fingerprint, we observe change in the microbial profile in those rats that we gavage with Rothia, as you can see in the figure 2A, but no change in microbial diversity, as pointed out on the figure 2B. One of the most important features that we observed here, it was an increase in the absolute abundance of Rothia mucilaginosa species in those rats that we gavage daily, as you can see in the figure 2C. In those rats that we stop gavaging with these microbes and we follow up for extra 4 weeks, the change in the astrocycles were still present. And rats that we previously gavaged with Rothia mucilaginosa still had abnormal astrocycles, as you can see in the figure 1D, as compared to control rats in figure 1C. More importantly, we also proved that at the end of this period, the species Rothia mucilaginosa, and specifically its absolute abundance, was still increased in these rats, as you can see in the figure 3A. And this tells us that Rothia mucilaginosa was engrafted in their small bowel microbiome. So in conclusions, we proved once again that female rats gavaged with Rothia mucilaginosa develops alterations in astrocycles, one of the most important features seen in PMOS. And after 1 month of gavage, as expected, we observe a high levels of absolute abundance of Rothia mucilaginosas in the small intestine of this animal. And this occurs without excessive disruption of the duodenal microbiome community. We also observe that this increase in absolute abundance of Rothia in the small bowel persists even when we stop gavaging these rats for extra 4 weeks. Thank you so much for watching.